in and out type stuff, but can we do a quick review? If you notice on the whiteboard, what did I put back up for you? The unit circle, aka just don't be surprised if the unit circle chart quiz comes up sometime in the near future. Know what I'm saying here? Make sure you're able to work with it, and also don't be surprised if you get hot quizzes on parent functions as well, and the graphs that you need to know for those. All right, so today we're going to take what is on the unit circle and we're actually going to change it to more of like an XY axis where we have a stretch. So here's what I mean. First of all, when we work with this, we're going to let this be our degrees and radians this time around. Okay, so basically our rotations now just became our input values, and we're going to be stretching it out. So for instance, if I said this was like 90 degrees, that's also pi over 2 radians. Would you guys agree with me on that? Okay. Now, what is the largest output for sine or cosine did we have when we had our unit circle? What was the largest number we ever got? Now that's the input values, our output values, our ratios. The largest one we ever got was 1. Would you guys agree? Now, quickly check and make sure I'm right. A few people thought root 3 over 2 was bigger than 1. Throw in root 3 over 2 real quick on your calculator. Does someone mind doing that real quick? What's root 3 over 2? The input is the angle measurement, right? So that's like 360, 2 pi, 5 pi, like whatever those angles are. Output is going to always be our ratio values. What do we get? Okay, don't erase that off your calculator. Okay, guys, let's do another one. What's root 2 divided by 2? What's root 2 divided by 2? No, root 2 divided by 2. 0.707. All right, so we're at 0.707. So the largest number we can have as an output is either going to be 1, or you can say the smallest number you're going to have is like a negative 1. Would you guys agree? Now, we're looking at a sine curve. Now, we're going to talk about degrees, but right away you're going to see me write everything down in radians because we're going to instantly turn it into radians, okay? So let's see if we can do this very quickly. So remember, my input's going to be in degrees, or aka most of the time radians. What's 0 degrees in radians? How many radians is there in 0? Okay, guys, I really wanted it to be that simple. I really did. Okay, what is 30 degrees in radians? All right, so this was my pi over 6 radians. What's 45 degrees in radians? Pi over 4. Awesome. 60 degrees in radians. All right, so we get the fact that is going to be pi over 3. And then 90 we know is what? Pi over 2. All right, now let's do our output. Our output are going to be our ratios. And this is for our equation. Y equals sine of x. So we're doing our input, our angles into our sine function. So guys, what's the sine of 0? 0. What is the sine of 30 degrees or the sine of pi over 6? 1/2. What is the sine of 45? That's root 2 over 2. Emery, what was that as a decimal? 0.707. Excellent. All right, guys, pi over 3. What's the sine of pi over 3? Root 3 over 2. But the decimal approximation, Braille, what did you get? 0.866. And then, guys, what did we get the sine of 90 or sine of pi over 2 to be? 1. Okay. So let's put this in a graph. Let's put this at 1. Let's have this be at negative 1. I'm going to put pi over, well, actually, let's put 45 degrees, and then I'll put the radians below it. That's pi over 4. So I'm going to have something here about 30 degrees. This would be about 60 degrees, right, my friends? Now, let's graph their outputs, because this output is my y value. Remember that x is my input, which is my angle measurement. So at 0 degrees, or 0 radians, we're at 0. Let's see if I can put, make sure I can move this. Is this going to move today? Yeah. So we're at 0, 0. Now, over 6 at 30, we were at what value? 1/2. Is that pretty close to about 1/2? And then pi over 4, what do we get? That was our 0.707, so something about right in here. And then at 60 degrees, we're over here at 0.866, which would be about right here. And then at 90, what value did we get? All right, we got 1. Beautiful. Now, is that a straight line? No, it's a what? Isn't that, oops, did not need to do that. And we go out. Taking that out. What did I get? Reset to. There we go. Okay. Would you guys, I have this, I keep pushing the zoom button. Didn't mean to do it. Can we not do anything here, please? I'm scared. That's the writing one. Don't want the writing one. Is it going to come off if I stop that? I
Hit the zoom one and then hit reset zoom.
I need to go and reset. Here we go. Reset zoom. Okay, but I don't want to use it. So can I get it off of this? Exit drop. There we go. All right. Love technology. Or sorry, guys. Sarcasm. All right. When we have this one, did you guys see a nice curve? Okay. Now, that's just through 90 degrees. How many degrees is on a unit circle? 360. All right, so let's have a little bit of fun and see if we can predict it a little bit more. Okay, what if I went through right here, 180 degrees, and I go to pi? What do you think that graph is looking like? What would it do? Would it go back down? We start curving down? Yeah, think about it. When I'm working on this, do I have basically a curve like that? Didn't I start going really high up to 1 on my unit circle, and then did I start going back down again? Okay, so here's my question. What if I went all the way over here to like 270? What do you think is going to happen to my graph? Am I going to be above or below the x-axis? What are my output values down here for sine? Positive or negative? So if my output's negative, it's going to be what? Below. How about if we see what the whole graph looks like? Let's use our calculator to do that. Yeah, it's going to be a beautiful, guys, think about physics. What did sound waves look like? Up, down, you know, that beautiful oscillating wave that you work with. All right, and we're going to let our calculators do the work. So this is where I'm going to be trying to go between the calculator and working with this. So we're going to clear the screen. First of all, guys, if people have been using my calculator, it might be in the right mode, but right now, we're going to change this into radians because we're going to graph, it's easier to use the radians to graph this stuff. So we're going to go into mode and make sure that you arrow down and you highlight radian and hit enter to make sure we're in radian mode, no longer in degree mode when it comes to graphing. And to get out of that page, you just go second and go to the mode key one more time and quit. All right, now we got to make sure a couple things are on here and you got to check with mine specifically. First of all, go second y equals and make sure that all the stat plots are off. So on your calculator, second y equals, are all the stat plots off? Hopefully yours not turned on. You go, you literally could just arrow down to number 4 and turn them on. And just go to number 4. Yep, go up to 4, up to 4. Hit enter. And off. Hit enter one more time. Boom, all stats off, which is what you need. All right, so first of all, you want that to be off. All right, now just go to y equals. And when you're there, we need to plug in sine of x. All right, so all you have to do is sine. Do you guys remember where you get your variable from on your calculator from doing this last year and everything? It's just the variable key, which is just to the right of it, and put in x. So what we're saying is our input is radians now when we're working with it. Now, normally we go zoom and we go 6 or zoom 4 or something like that when we're graphing. I don't want you to do this time. This time I want you to do a very specific Windows setting. How do I control the Windows setting? Well, to do that, you go to the window key, okay? Now, in the Windows setting, if you look at the bottom of our notes, it says use your graphing calculator to graph y equals sine x, and it says the following. On the window from 0 to 2 pi, which means my x min needs to be what? 0. So I'm going to put 0. And then my x max, you literally just got to put in there 2 pi. So it goes 2 pi. To get the pi key, remember just go second and then the caret key. And then our x scale, I want to be pi over 2. So you go to x scale, which just gives us up in quarters. And the thing about it's like when we're going around the unit circle, then you just got to go second pi, and you can literally go divided by 2, and that would put it as pi over 2. And then your y min and your y max, just put them at -3 and 3. It just gives us a nice looking graph to look at. And then our y scale, leave it at 1 if it's not at 1. Make sure it is there. So because you guys basically, and if you hit enter here, notice it goes 1.57. It just changes it to the decimal version of that. Yes, ma'am.
My thing has one that says shade red.
Yeah, so does mine.
Shade
All the way
red.
on top. All the way on top.
Yeah, it's all the way.
It says 6.
I don't have that.
I have no idea what that's for, so don't touch it. So I'm not taking anything out of it. I'm not going to do anything with it. So staying out of it. So when you're doing this, my friends, now hit the graph key. Were we right? What would happen to that curve? Yeah, the cool thing is we were right. Now think about it. This is really what this is representing. From here to here is representing the first quadrant. From pi over 2 to pi, that's my second quadrant. Then we got negative output values for sine for the next 2 quadrants. So really, it's just like we went around that lovely circle. Or I tell people, it's like you took the circle and you cut it, and then you just twisted it, basically is what you did. So keeping it kind of like that, let's put it on our graph. Guys, here's where putting scale is going to be very helpful for a moment. Start here at 0, go to 2 pi, put this at pi. Remember, our scale, our notches, are going to end up being pi over 2. This is going to be at 3. This is at -3. Now, taking what you see on your calculator screen, and even with what we did earlier, where did we start and end with this graph? Didn't we start at 0, correct? And didn't we end at 0? Let's make sure we are writing this stuff out. Guys, can we please make sure we're setting up? Like, it is just kind of rude when I'm putting everything and people are falling asleep or they're not giving full attention. It's just not nice. Okay? Now, what happened between 0 and pi? How high did we get? To what value? And you can even trace if you want to. We got up to 1, which makes sense because sine of pi over 2 is 1. Guys, and over here at 3 pi over 2, what did we get down to? -1. So this is going to be our graph. Now, this is for number 1. Now look at number 2. On number 2, they say, hey, do the same thing, but just change your scale to a -2 pi to 2 pi. So basically, is it saying, hey, can I go the opposite direction around my unit circle? Would you guys agree with me? Because can we go either positive or negative direction? Absolutely. So this would be over here at -2 pi. This would be at 2 pi. 0, put 3, -3. All right, we're going to go back into our calculator screen. Go to Windows. And the only thing you need to change this time is put a -2 pi. Remember, your negative sign is on the very bottom of your calculator. So go -2, second, put in the pi, and enter. It should be the exact same thing as your x max, but with a negative in front of it. And that's the only thing you need to do. And then go back and push the graph key. Yes, sir. Yep. All right, guys, what do you see? Did everyone get it?
Same thing but longer.
Is it supposed to look like this?
Is it supposed to look like this? Did you match what you see on my screen? Oh, guys, I forgot to tell you today. I literally had Mrs. Hockett come in to do teaching, and I lost my Surface pen, so I couldn't write on my Surface. It was awesome. It was a beautiful moment. It was a good day. All right, she laughed at me, thankfully. All right, so guys, is it repeating? But I want you to think about it logically. If I was to start at 0 and go in the negative direction, shouldn't I have negative sign values? And then once I get to -pi, wouldn't I start getting positive ones by going through with it? So really, really, isn't it just matching what our circle says to do? So it's really just taking our unit circle and putting it out there for us. So let's draw this real quick because it's something you need to be able to do. And when we have these, here's the easy way of graphing it, is putting it at your pi's, putting it in the zeros, and noticing you get the exact same type of scenario going through, and see if you can make it in a nice pretty curve. By the way, if you come with straight lines with curves, I don't give credit, so just know you might want to make them pretty curvy. Just so you know, I'm kind of strict that way. Now, what do you see? What's something that's interesting on here? Notice anything? Are you surprised by what you see? Don't notice anything? It what? That's exactly what I wanted you to notice. It does what? It repeats. So I want you to think about it. If you are looking at graphs 1 and 2, what do you predict will happen if I go to the graph of the sine function and I go, all right, we're not going from negative 2 pi anymore to 2 pi. I'm going all the way. We're changing it. So this is at negative 4 pi. This would be at 2 pi. Over here would be at 2 pi. And this would be at 4 pi. I'm going to put this at a 1. This is at negative 1. What would you think it would look like? What would it look like on the right? Would it look just like what we graphed earlier? And get something that looks kind of like this? Would you guys agree? Would it happen again? Yeah. So if it goes that way to the right, would it happen the same way going to the left? And what we noticed before, we're like, oh yeah, it goes down, it goes up halfway, we could cross, we're going to go again, halfway. Sorry if I'm a really bad grapher freehanding, I need graph paper. But doesn't it just keep on going? Because what does it do? It repeats. And how many times does it repeat? Or when does it repeat? Let's put it this way, when does it repeat? Always. What else? How far? I heard it. 2 what? Every time it's 2 what? Every time I go a distance of 2 pi, did I go high, then I go low in my graph? Yeah. So the fact is, every 2 pi, it repeats. This has a formal name. This is a true-false question on quizzes and tests. Are you ready? If you have a graph that just continually repeats, and by the way, it doesn't end. You could keep adding on, and it would keep on going. It is called a periodic function because there's a set distance, a set period when I go through my whole graph once, and then once I go that distance again, I go through it wholly through again. So it has a period or a distance that it repeats of 2 pi. Does not mean it will stay at 2 pi, but that's the idea behind it. Okay, let's keep on going with this. So sine functions are periodic. They go on forever. Think about sound waves and stuff like that. Can they keep going on forever? Just keep on that ripple effect. It's called a periodic function. All right, now we're going to do the same thing that we did with sine. We're going to do it with cosine on our calculator. So go on to our calculators, go to your y equals, and just put cosine instead. Cool thing is once you punch cosine, the x stays, so it's pretty awesome. But I want to start again from 0 to 2 pi because I want you to notice the difference on here. So just go into your Windows setting and take your x min and just put it at 0. Leave x max at your 6.28, which is your 2 pi, and then go to graph. Now, I have a feeling you're not surprised that it's a curve. But what's different between the two graphs? Is it less aggressive curve? It feels shallow. Okay, what if I'm gonna put something here. I didn't do this in the other class, but I'm gonna put the other one on here real quick. Is it less aggressive or is it just slightly different? It starts at a what? It starts at the same spot, but where you cross the x-axis does what? That's the change. Doesn't it look like that? I think that's the coolest looking graph. I really do think that's cool looking. Sorry, nerd factor 101's coming through on this one. But what's the difference? At the sine curve, I start where? The red is sine curve. Where do I start? Where did I start on the cosine curve? Guys, what's the cosine of 0? Make sense? Yeah, that makes sense, right? It's just where it's starting on that graph. So let's go ahead and graph it real quick. We're just going to put in our cosine. We're going to go from 0 to 2 pi to pi. The difference is this time, I start at 1, and where did I end at with the cosine curve? Didn't we also end at 2 pi? I mean, not at 1, excuse me, at 2 pi, we ended at 1. All right, also, what else happened? What happened at pi? We're down here at what? -1. Then, halfway between, we get our zeros. So, guys, here's the hardest one to draw. For some reason, it's harder for people to draw the cosine curve than the sine curve. I'm not sure why. It just is. Please make sure it is curvy. All right, going back with this, I'm going to go into the calculator. I'm going to take off, just for the time being, the cosine curve. We're going to go into our windows. And I want to go from -2 pi to 2 pi again. So we're going to go negative, plug in pi, and then we're going to hit graph. Oh, look, what happened? A lot more curves. Does this one repeat itself as well? Yeah, because, now remember, I started from here to here on the first one. Did I have the exact same thing happening? The exact same distance. So is this a repetitious curve as well? Does it keep going on forever? And the answer is yes. So let's put this in our graph here real quick, just so we can see the difference between the two curves. So this is going to be -2 pi. This is going to be 2 pi. Pi. Negative pi. 1. -1. And then we're going to put in our graphs, because these are easier to do. Notice I put the end of the curves in first. I put 1 and 1. I go halfway, get pi. Put in the zeros. Then I know where my values end. And then putting the lovely curve. Now, honestly, if it didn't say to be equal to, I could have arrows that say these go on forever. But since they said equal to, they limited what we could show. Now, quick question with this. Does that make the cosine function also a periodic function? Does it repeat itself? Yes. Now, it is a periodic function. What is the period of cosine? Because these are the cosine curves. So this is y equals cosine x. Y equals cosine x. How long does it take before it starts repeating itself? Exact same thing as sine curve. Keep that in the back pocket, all right? This is information that's really helpful. Both sine and cosine repeat at a distance of 2 pi. They have a period of 2 pi. All right, now, how can I graph these well? Okay, here's the rules with Mr. Smith and myself, and I taught this to my advanced geometry, my advanced precalculus when I did this too. I always have to see 5 points, okay? Most of the time, for sake of time, we only ever have you graph 1 period worth, but the thing you need to know is that you should always have 5 points on the graph that I can easily distinguish and use. Also, the first thing you will always graph is going to be like the period of the function. So you want to know where it starts and you want to know where it ends. And I will show you more specifically when we are working with it later in more detail. But here's the first thing you do. Always put your scale down. Scale matters. No scale. Credit doesn't get given. Also, if you're really good at scale, it saves you from having to redraw stuff. It's beautiful. So we're going to be really simple. So here's the first thing you always do first. Number 1. Start at the ends. And put your point where? at what point? 0. So at 0 and 2 pi, put in your point. Go halfway and put the third 0 right here. So think about it. Always start at the ends. You put in your zeros. No matter what sine curve, what's the period, I always put the ends at 0. Go halfway, and you will put in perfectly the other 0. Then go half of the halves to mark at 1 and -1. Okay, so we're literally dividing this into quarters and halves. So what do I mean by the first half? All right, what's halfway between 0 and pi? Pi over 2. That's where you plug in your +1. So I'm putting that in gold. Then I go to my other half that is marked, and that goes from 0 to what? 2 pi. What do I put down for my other point? At 3 pi over 2, I'm going to have a -1. So we go half. Oops, that's really low. Let's see if I can eyeball it a little bit better. Half of the half. So that is 1 period worth of a sine curve. So always start at the ends and then always go halfway. Are you guys with me on that? For sine or cosine, we always start at the ends, marking those points, and then base everything else off of them. Guys, was that really hard to graph those 5 points? Especially 3 of them were really easy. Would you agree? Okay, what's the rules for cosine? Guess what? Guess how many points you still need? You still need 5 points. You're still going to start at a period of 2 pi. Okay, so we're going to put here 0. We're going to have 2 pi. I'm going to put pi here, 1, -1, when we're working with it. Okay, just like before, on number 1, start at the ends of the period. Okay, and mark at 1. So again, the period is 2 pi, so we mark it at 1. So we're at 1, and we're at 1. Now, what did I tell you to do on sines? Go where? After I mark the ends, we always go what spot? All right, so the same thing here. Go halfway and mark at what value though? -1. So just halfway between our endpoints, we're going to go the opposite direction and go -1. Now, that's 3 points. How many do I need again? So then do the same thing we did again. Go to the half of the halves and mark your zeros. So half of the halves again, from 0 to pi. Oh, I'm going to be crossing the x-axis at pi over 2. And then my other second half, I'm sure I can put that here. Cool thing, it works either way. I'm still at my 0. Now, again, guys, be really good. Make sure you can do the curve when you're doing those. So, always think of everything as in like halves and quarters. If you think everything in halves and quarters, you can graph these really efficiently and really, really well. All right, let's go to the next page. Are you guys good with me so far? Okay, let's see if you can do these without looking on that last page, just using patterns that we've seen so far. Now, they said how much to graph on the first 2. So what's the length of the period for both of them? 2 pi. So isn't it easy to just go from 0 to 2 pi? Would you guys agree? So making sure that you'd sit there, and I'd go 0 to 2 pi on both of these. And again, picking the scale that you want. I'm just going to keep these pretty simple, put that talk me through the sine curve. Where do we always start on either one? Always start at the what? Always start at the ends. So with the sine curve, where do the ends land? Perfect. 0 and 2 pi. Then I go where? Halfway. And I get another what? Getting another 0? Yeah, so this one, you get another 0. So remember, the sine curve, 3 zeros. The ends and halfway. Then go half of your half and go what? Up or down? Up. Awesome. Mark 1. Go to your second half and go which way? Yeah, is this making sense? Okay, good. And I only need to do a 1 period worth. Again, we know they keep on going. We're just only showing a portion of it to make our lives easier. Okay, let's talk about cosine. Where do we start?
1.
All right, yeah, we start at the ends and they mark them both at 1. So right here, I'm going to use green. I think it's a good color. Here's that 1. Here's that 1. Then where do we go no matter what? To the half. But do we mark a 0 this time? No, we mark a what? Negative 1. Then, always go half of the halves. What's half of the halves? What is cosine? This one's at 0, that's right. So the half of the halves are your 2 zeros. By the way, this is the hardest one for everyone to draw, including this person. The only person I know who draws perfect sine curves is Felinsky, and I don't like, or cosine curves is Mr. Felinsky. He doesn't count because he's like Mr. Felinsky. You know what I'm saying? Smith and I, we're not that perfect. All right. Do you guys think you could do 2 periods worth of each one? Go for it. Go for it. Notice the first one's cosine, the second one is sine x. So this is just making you find the pattern.
He's asking for more than 1 period. Can we put more than, do we stop at 5 points? Do you have to have 10?
You should always do, well, it's basic one actually ends up being, but because it shares the network, so we should. See, I would have gone to the negative side, but as long as you have that, you're in a good spot. It's not bad, is it, with the pattern? See, I would have gone negative 2 pi to pi, but Brielle went from 0 to 4 pi, which is beautiful. It works. I'm happy with that. The scale, that's a lot for us.
Okay.
That's totally how I do it. That's how I would do it. Brielle is just doing a great way of doing it as well. Guys, you have to kind of I do like individuality that's correct, okay? I just want you to know that. Individuality that is spot on correct is a beautiful thing. It's a beautiful thing. And I'm just going to go in and mark my other one. So I have my scale. Make sure you're marking the right ones. Make sure cosine's your first one, sine's your second. Let's see if I can do these. My screen stopped. Okay, good. Friends, did you have, I went from 0 to 2 pi, negative 2 pi to 2 pi to get my 2 periods in. Let me make sure it's over. Or, there's a few of you who did from 4 pi to 2 pi like this. If that's the case, shouldn't you have had something that looked like that? Would you agree? Except for my axis went away. Hopefully that would help a little bit. So those are both correct ways of doing it. Are you guys with me? As long as you showed 2 periods worth. All right, that's the cosine. Again, let's try this real quick. If I'm graphing cosine, where do you start?
At 1.
At the ends, and then you go at 1, right? Then you go halfway, go negative 1, and the half and the halves are your zeros. At sine, where do we start? at the ends, but they're at zeros, correct? And I'm just going to go ahead and throw those in. And then I do what? Half of them is also the other what? Zeros. So going from 0 to 2 pi, halfway is at pi. From negative 2 pi to 0, halfway is at negative pi. Going halfway. Then you go half the halves on sine. What do? We go from 0 to pi, we go up 1. And then 0 to 2 pi, we go what? Down to negative 1. Go half of the halves. And then keep the pattern going. How'd you guys do? If I was to ask you Thursday class, being class, and I just gave you 2 graphs, and I said, graph for me the sine curve, the cosine curve, could you do it from memory?
Yeah.
That's how you got to get that good. Are you guys with me on that? You need to know it from memory. It's kind of like your unit circle. You guys are all going to be reviewing it, so that way you ace the unit chart quiz that could be coming up in the next week or so. Right? Everyone's like, yes. Crap, I gotta review that. All right, are you guys feeling okay with that? Are we positive that we feel okay with that?
Yeah.
All right, we're in a good spot.